Hello everyone and welcome back. I am Benjamin Williams and today we will be doing another Boson NetSim lab. We're still within the infrastructure section within Boson, and today our lab will be on configuring virtual router redundancy protocol number 2. So let's get into our objective for this lab. It says configure virtual router redundancy protocol VRRP and verify the configuration. All right, so let's get into our lab topology. It says the topology diagram below represents the net map in the simulator. For this lab, your network design includes 4 switches: A switch 1, A switch 2, distribution switch 1, and distribution switch 2. So we can see our distribution switches right here and our access layer switches right here. It says A switch 1 and A switch 2 are layer 2 switches, and D switch 1 and D switch 2 are distribution layer 3 switches. D switch 1 and D switch 2 will be referred to as routers throughout the lab. Layer 3 switches are capable of transmitting data at layer 2 switch speeds, but can also determine for themselves how traffic should flow at layer 3. So yes, that is correct. So we can also take a look at our lab topology and see that we have 2 routers. We have router 1 and router 2, and they look to be within OSPF area 0 with a process ID of 10. On distribution switches, it looks like the fast Ethernet 01 and fast Ethernet 01 on the distribution switches are in area 1, and they're VLAN 10. They're configured to be in VLAN 10. And it looks like down here, our fast Ethernet 011 on D switch 1 and fast Ethernet 012 on D switch 2 looks to be in OSPF process 10, and that is in area 2. And those are configured to be in VLAN 200. Okay, we have a port channel between D switch 1 and D switch 2, which allows us to combine both of these physical connections. So we have redundancy, and then we can also combine the throughput for both of these gigabit interfaces as well. So it allows for more throughput and then also redundancy as well with these port channels that we have between the distribution switches. And it looks like PC1 is connected to VLAN 100, PC2 is connected to VLAN 200, and our access layer, of course, our access layer switches give our PCs or our end devices connectivity to the network. Okay, so that is a little bit about the topology that we're working with. I've already read through all of the commands for this lab and also the descriptions. And I've also looked through all of the IP address information, and this is also good information to have for troubleshooting purposes, as well as to confirm that all of the interfaces within each device has the correct IP address as well as the correct subnet mask. Okay, so let's go ahead and get into our lab task. We're going to keep the topology up here in the top left. We're going to do our lab task reading top right, and we're going to do all of our configurations down here at the bottom, of course. Okay, so let's go ahead and get into task 1. It says verify basic connectivity. It says verify all 9 VRRP IP addresses on each device by using the proper show commands in the IP addresses table. All right, so let's start on router 1, and I'm going to scroll down to our IP address table information so we can confirm all of our IP addresses. So let's do an enable for privilege exec mode, and let's do a show IP interface brief on router 1. And starting out with the fast Ethernet 00 interface, we have an IP address of 198.51.100.1 that matches up here in our IP address table. Fast Ethernet 01 has an IP address of 198.51.100.5 that matches in our IP address table. And the loopback 0 interface has an IP address of 1.1.1.1, and that matches in our IP address table. So let's move on to router 2. Let's do an enable. Let's do a show IP interface brief. All right, our fast Ethernet 00 IP address is 198.51.100.2. That matches in our IP address table. Our fast Ethernet 01 has an IP address of 198.51.100.9. That matches in our IP address table. And the loopback 0 interface has an IP address of 2.2.2.2, and that also matches in our IP address table. So let's move on to distribution switch 1. Let's do an enable. Let's do a show IP interface brief. All right, VLAN 1 it's not configured. So let's start out with VLAN 100. It has an IP address of 10.10.100.10 that matches in our IP address table. VLAN 200 has an IP address of 10.10.200.10 that matches for our VLAN 200 interface. And the Fast Ethernet 01 IP address is 198.51.100.6, and that matches in our IP address table. So that looks good. Let's go ahead and move on to distribution switch 2. Let's do an enable. Let's do a show IP interface brief. Interface brief. All right, VLAN 100 has an IP address of 10.10.100.20. That matches in our IP address table. VLAN 200 has an IP address of 10.10.200.20. That matches in our IP address table. And the Fast Ethernet 01 IP address has an IP address of 198.51.100.10. That matches in our IP address table. Okay, so let's go ahead and move on to our access layer switches. Let's do an enable. Let's do a show IP interface brief. Brief. Oops. Brief. Let's do a exit, escape. Didn't want this in full screen mode, but I guess I can't. There we go. All right, let's confirm its IP address for the VLAN 100 interface, which is 10.10.100.11. That matches in our IP address table. Let's go to A switch 2. Let's do an enable. Let's do a show IP interface brief. All right, and for VLAN 200 on this access layer switch, we have an IP address of 10.10.200.11, and that matches in our IP address table. So lastly, let's do the PCs. Let's do an IP config /all. All right, we can see that PC1 has an IP address of 10.10.100.111, and that matches. It has a /24 subnet mask that matches, and the default gateway is 10.10.100.1. This is the default gateway right now, but this is probably going to be the virtual router redundancy default gateway. So let's just confirm on PC2 as well. Let's do an IP config /all. All right. Let's just confirm the IP address and subnet mask. The IP address is 10.10.200.222, and that matches, and it has a /24 subnet mask. So that matches as well. So let's go ahead and move on to number 2. It says verify that PC1 can ping dswitch1's virtual LAN VLAN 100 interface, which has an IP address of 10.10.100.10. So let's go to PC1, and let's do a ping to 10.10.100.10. And yes, we can ping dswitch1's VLAN 100 interface. So we have 5 sent and 5 received, so that looks good. Go to PC2. Let's do a ping to 10.10.200.20, because that's what it says for number 3. And it's pinging dswitch2's VLAN 200 interface. And we can ping dswitch2's VLAN 200 interface, which had an IP address of 10.10.200.20. So yes, we are able to ping dswitch2's VLAN 200 interface from PC1. And number 4, it says verify that PC1 and PC2 can ping router 1's loopback 0 interface, which has an IP address of 1.1.1.1. Let's start on PC1. Let's do a ping to 1.1.1.1. And yes, we are able to ping router 1's loopback 0 interface from PC1. Let's confirm that we can do the same on PC2. Let's do a ping to 1.1.1.1. And yes, we are able to ping router 1's loopback 0 interface from PC2 as well. So that everything looks good for task number 1. So task number 2, it says verify virtual router redundancy protocol for VLAN 100. It says this task involves configuring VRRP for VLAN 100 on the distribution layer switches. The functionality and setup of VRRP is very similar to that of Hot Standby Routing Protocol, HSRP. However, there are some important differences. Yes. So number 1, it says the VLAN 100 interface on both dswitch1 and dswitch2 create a virtual router redundancy group with a group number of 100 and an IP address of 10.10.100.1. Okay, so let's go ahead and do that. Let's go to dswitch1 first. All right, And let's do a configure terminal to go into global configuration mode. And let's do an interface VLAN 100 to go into the interface configuration for VLAN 100. And let's do VRRP. We want to do a group of 100, and we want to give it an IP address of 10.10.100.1. All right. We can see that it has taken over as the master switch or the master router for this group 100. All right. So let's do the same thing on D switch 2. Let's do a configure terminal. Let's go into interface VLAN 100. And let's do VRRP 100, an IP address of 10.10.100.1. All right, so we can see that it has taken over as the master router. And the reason that it has is because D switch 2 has a higher IP address on the VLAN 100 interface, as we can see right here. Okay, so D switch 1 has an IP address of 10.10.100.10, and D switch 2 has an IP address of 10.10.100.20. So that's why D switch 2 took over as the master router. Okay, so number 2, it says VLAN 100 workstations and A switch 1 should use the newly configured virtual router redundancy protocol IP address as their default gateways. On PC 1, configure the default gateway to be 10.10.100.1. Let's go to PC 1. Okay, and let's do IP config / default gateway, and let's do 10.10.10. Something's going on. Okay, 10.10.100.1. All right, so we just configured its newly default gateway, and on A switch 1 it says configure the default gateway to be 10.10.100.1. So let's go to A switch 1. Let's go into global configuration mode, conf T, and let's do an IP default gateway of 10.10.100.1. Okay, and that looks good for task number 2. So let's move on to task number 3. It says configure virtual router redundancy protocol for VLAN 200. It says this task involves configuring virtual router redundancy protocol for VLAN. This is supposed to say 200. It's saying 100 on the distribution layer switches. The functionality and setup for virtual router redundancy is very similar to that of hot standby routing protocol, HSRP. However, there are some important differences. So it says on VLAN 200 interfaces on both D switch 1 and D switch 2, create a virtual router redundancy protocol group with a group number of 200 and an IP address of 10.10.200.1. Okay, let's go to D switch 2 first, or D switch 1 first. I'm sorry. Let's do an exit to get out of the interface VLAN 100, and let's go into interface VLAN 200, and let's do VRRP 200. Let's do an IP address of 10.10.200.1. Okay, do the same thing over here on D switch 2. So let's give an exit. Let's go into interface VLAN 200. Let's give a virtual router redundancy protocol group of 200, and let's do the IP address of 10.10.200.1. All right, and as we can see, it is the master, and D switch 1 will be the backup. And the reason that it will, so right here I actually fat fingered it, or didn't even fat finger it. I made a typo. I didn't put 200 instead of, I put 20 instead of 200. So let's do a no VRRP 20 IP address 10.10.200.1, and let's do a VRRP 200 IP address of 10.10.200.1. That looks good. Yeah, so that's what we want to see. We want a group of 200. Okay. All right. So let's go ahead and move on to number 2. It says VLAN 200 workstations and A switch 2 should use the newly configured virtual router redundancy protocol IP address as their default gateway. On PC 2, configure the default gateway to be 10.10.200.1. All right, so let's go to PC 2. Let's do an IP config / default gateway of 10.10.200.1. And let's go to A switch 2, and let's do conf t, let's go do an IP default gateway of 10.10.200.1. All right. And that looks to be good. We just did the access. We just did step number 3 as well. So now task number 4, it says verify virtual router redundancy protocol configuration. This task involves verifying virtual router redundancy protocol on distribution switches. Okay, so it says on D switch 1 and D switch 2, display the VRRP configurations. You will use this output to answer the next 3 questions. So let's go to D switch 1 first, and let's do a do show VRRP. And let's do the same thing on D switch 2. Let's do a do show VRRP. All right. So the first question is asking, which device is the master for VLAN 100? How do you determine this? Well, if we look at our output for VLAN 100, we can see that D switch 2 is the master. And for D switch 1, we can see that it is the backup for VLAN 100. And we determined this by just looking at the output. We can see that it says that D switch 2 is the master. Okay. So question number 3 is asking, which device has the higher priority for VLAN 100? Well, they both have the default priority of 100. We can see that this is for D switch 2. It has a priority of 100, which is the default. If we go over to D switch 1, it also has the default priority of 100. Okay. So they both share the same priority. Question number 4 is asking, which device is the master for VLAN 200 and why? Well, if we look at the output, we can see that D switch 1 is the backup for VLAN 200. And if we look at D switch 2, we can see that it is the master for group 200. Okay. All right. So step number 5, it says verify that PC1 can ping. I forgot to answer that. It says, why is it the master? It's the master because, like I said, D switch 2 has a higher interface IP address for VLAN 200. So in that case, it's always going to be the master, okay? Unless we configure the priority to be higher on D switch 1. All right, so step number 5, it says verify that PC1 can ping, or can still ping router 1's loopback 0 interface, which has an IP address of 1.1.1.1. Okay, so let's go ahead and do that. Let's do a ping to 1.1.1.1. And yes, we are still able to ping router 1's loopback 0 interface. As we can see, we have 5 sent and 5 received with our pings. Step number 6, it says verify that PC2 can still ping router 1's loopback 0 interface. So let's do that. Let's do a ping from PC2 to 1.1.1.1. And can we still ping? I don't know if I fat fingered it or if we just can't ping. Okay, so let's troubleshoot, because it looks like we cannot ping the loopback 0 interface. So I configured the correct the default gateway. It looks like we wanted to configure that to be 10.10.200.1. Let me just confirm that. 200.1. Yes. And let me make sure that we needed to configure the default gateway on A switch 2 to be 10.10.200.1. Yes, that looks good. Let's do an IP config /all. Looks to have the correct default gateway. It looks to be in the same subnet for its IP address. Not sure why those pings failed. Huh. Let's see. Yeah, saying that they should have been successful. Huh. Let's see if we can ping. Let's see if we can ping our default gateway. Let's ping 10.10.200.1. So we're able to ping D switch 2. We're able to ping D switch 2. Huh. Let's see if we can ping router one's. Let's see if we can ping router one's fast Ethernet 00 interface. Let's do a ping to 198.51.100.9. So we're not able to ping router one's fast Ethernet 01's interface either. That is weird. Let's go to a switch 2. We configured the correct default gateway. Yeah, we configured the correct default gateway. And on PC2, it has the correct default gateway. Yeah, I'm not sure. This one has me a little bit stumped. Hopefully, oh yeah, we could do a trace route. We can see let's do a trace RT to 1.1.1.1. Yeah, so we're not able to. Let's go to D switch 2. Not sure why we're not able to ping, but I know when we grade, if we did something wrong, it's going to tell us. So let me just do. We're just going to do it on PC1, and then it should tell us what we did wrong at the end. So let's do a trace. Right now, let's just do a trace RT to 1.1.1.1. Yeah, so PC1 is still able to communicate, and we did all of the same configuration on PC2, so I'm not sure what's going on with it. Before we were able to ping, but now we're not, so I'm not sure what is going on with it. All right, but let's go ahead and go to task number 5. It says assign virtual router redundancy protocol priorities and preemption. It says this task involves verifying virtual router redundancy protocol on the distribution switches. All right, so it says, how can you guarantee that a specific virtual router redundancy protocol router becomes the master in a VRRP group? Well, we just have to make sure that it has a higher priority than the other router for it to become the master router. Okay, because we already know that preemption is enabled by default with virtual router redundancy protocol. So it says assign virtual router redundancy protocol group 100 on D switch 2 a priority of 90. So let's go to D switch 2 and let's do a V. Well, let me make sure. Let me do an exit. Let's go to interface VLAN 100 and let's do VRRP group 100 and have a priority of 90. Okay. So as we can see, it is now the backup, and now D switch 1 should be the master for group 100, and that is correct. So that looks good. It says, what should you do to guarantee that D switch 1 remains the master and VRRP group 100 in case an additional switch joins the VRRP group? Well, we need to configure D switch 1 to have a higher priority than the default. Okay, so it says for step number 4, it says assign virtual router redundancy protocol group 100 on D switch 1 a priority of 120. So yes, we're going to go ahead and do that now. Let's do an exit. Let's go to interface VLAN 100 and let's do a VRRP 100. Let's give a priority of 120. All right. It says verify that the priorities are configured correctly. So let's do that. Let's do a do show. Oops. Okay, let's go back right there. Let's do a do show VRRP. Let's do the same thing on D switch 2. Let's do a do show VRRP. And as we can see, we configured D switch 2 to have a priority of 90 for the group 100. And D switch 1 should have a priority of 120 for group 100. So that looks correct. All right, it says, has D switch 1 become the master for virtual router redundancy protocol group 100? If so, why not? And it has became the master, as we can see from the output from the CLI. So it is the master for group 100. All right, question 7 is asking, do you need to enable preemption on virtual router redundancy protocol group 100 for D-switch 1 and D-switch 2? And we do not, because preemption is already enabled by default with virtual router redundancy protocol, okay? So it says verify that connectivity still exists on PC1 and PC2 by issuing a ping to router 1's loopback zeros interface, which has an IP address of 1.1.1.1. So we know that this is going to work on PC1, but I'm still sure that, yeah, it's not going to work for PC2. We're still trying to, yeah. So let's do a ping to 1.1.1.1, and we're not able to ping from PC2. So yeah, we'll figure that out here soon. And question number 9, this says on D-switch 2, assign virtual router redundancy protocol group 200 a priority of 90. So let's go to D-switch 1, and let's do an exit. Let's go into interface VLAN 200, and let's do a VRRP 200 with a priority of 90. All right, let's go to D-switch 2. Let's do an exit. Let's go to interface VLAN 200. Let's do a VRRP 200. Priority of 120. Hit enter there. All right. So we just did steps 9 and 10. All right, and it says from PC1, trace route to router 1's loopback 0 interface. And it's asking what is the device's first hop, and the first hop should be for PC1. It should be, let's check, D-switch 1's IP address. Yeah, it should be D-switch 1's IP address. So let's do a trace route, trace RT to 1.1.1.1. And we look at the IP address, and as its first hop is 10.10.100.10. If we look at the IP address, that is D-switch 1's VLAN 100 interface. Let's put our topology back right there. And it's asking us to trace route to loopback zeros interface on PC2, but we know that we're having trouble. So that looks to be the end of the lab. So let's take a look at, let's grade first and see if we did any misconfiguration on PC2 or this access switch 2. So let's hit grade. And it looks like everything is correct. So I think that Boson is having an issue because we did, and I was thinking that I configured everything correctly as well. I think Boson is just having an issue right now with the ping on PC2 because everything is showing up as correct. I think it's just an error within Boson, but I appreciate you guys for watching this one, and I'll see you in the next one.